You should. Like this. They should be able to copy this. It does need, we might need to copy the rest of it. Copy and here. Okay, now it's ready. Hi everyone. I'm just going to get started. If you just came in, you can scan the QR code and get access to the slides. And yeah, I'll get started. So we are Girls Who Code. Me and Arashi are going to be hosting this workshop. It's called Intro to SQL. And we're basically going to be talking about basic SQL like queries. And yeah, I'll start by explaining exactly what SQL is. If anyone doesn't know, SQL stands for Structured Query Language. And basically, it's a way of querying databases that contain structured data. By structured data, I mean data that's like in tables. You have like a set number of columns and rows and things like that. It's structured as opposed to like a graph of data, for example, where you just have like an infinite number of like data points that are just connected to each other. This is structured in the way that it's all in a table or multiple tables. And SQL is used to query those tables and retrieve information from them or add information to them and things like that. Okay, so the objectives of today's workshop include learning about relational database management systems, something called data definition language, and something called data manipulation language. We'll start with relational databases. Relational databases just include data points and tables that are related to each other in some way. And so changes in one table might affect another table. Some tables might be dependent on other tables and things like that. Those are basically called relations between tables. A relational database is structured something like this, where you can have some tables that are dependent on each other. For example, here we have the student table and the department table. And we know that student and department are related through the student ID column. So if you have a student ID in the department table, it's referencing a particular student that their information is basically all in the student table. So for the first row, student 105 is in the CS department. And if you want to know who student 105 is, you can reference the student table. You can find out that it's John. I can barely see, but yeah, it's John. So, yeah, that's basically how it works. Now we can get into some terminology. So we can look at the big picture. We see two tables here. They're also called relations since this is a relational database. So these tables are, or relations, contain columns, which are also called fields. Columns like student ID, department name, and course. These are all also called fields. We also have rows, also called records or tuples, depending on the situation you're in. You can, for examining a database through Python, you might receive each row as its own tuple. That's why we also call them tuples. So for example, the first row in the student table, which is 101, John, computer, that would be its own tuple. And the last thing we're going to talk about is what's labeled as primary key and foreign key. So these are, this is a very integral concept in databases and relational databases in particular. This is how we define a relation between two tables. So in our first table, the student table, we have a student ID column, and you can see that each student ID represents a student. And each student ID is unique. It cannot be applied to another student, and it can never be a null value. So those are like properties of primary keys, basically. And because each ID represents a record or a row in the table, we are able to classify it as a primary key. Now, this does not mean that all tables that contain like unique non-null values in one of their columns are going to be primary key columns. It just means that when you create a table like department with the student ID column that's dependent on this student ID column from student, in that context, it's called a primary key. So when you have the student ID column of department dependent on the student ID column of student, the one from student is called a primary key, and the one from department is called a foreign key because they are referencing each other, basically. The student ID column in department is called a foreign key because that is the one that is dependent on the one in student. I know I said like primary key and foreign key and like student a lot, but does that make sense to everyone? More or less. You'll see it in practice when we actually write out the queries and actually create the tables with these columns. But just know that there is something called a primary key and a foreign key, and that's what defines relations between tables. Okay, so for this workshop, we're going to use a website called SQLfiddle.com. There's no particular reason behind it, just that you didn't need an account to use it, so I just chose that one. So go ahead and go to this website. I'll give you guys like 2 or 3 minutes, and then we can move on. Okay, so now we're going to begin talking about data definition language. Data definition language just encompasses the kind of queries in SQL that creates, alters, and deletes database objects. And you'll see more about what this means as we move through the slides. Let's start by creating our own table. So here we're creating a table called student. Based on the example I showed you earlier, it has 3 columns, the ID, the name, and the age. And I'm just going to explain what the syntax is like, what the conventions are, things like that. So you can see that I have create and table in caps. That's just a convention in most SQL languages. It's not required, but it's recommended to differentiate the SQL keywords from your own, like your own variables and your own names. So for example, student is our own table name that we defined. So we're keeping it in lowercase. Also, ideally, you would have this int and primary key in caps as well. But yeah, I guess I just forgot to do that. But most of the SQL keywords you're going to have in caps, and that's just convention. Moving on to the column definitions. So you can see that the column definitions follow this sort of layout where you have the column name, the data type, and the constraint that we're applying on that column. So for the first row, we have the column name called ID. We have a data type defined as int, and we have a constraint applied to that column, which is called the primary key constraint. And this is where the relation sort of starts to come in. We haven't defined any other tables yet, but if we were to, then we could reference this column from that other table by defining another column as a foreign key. The reference is this ID column here. And you can see that in the other rows, we don't have any constraints defined, but if we wanted to, we could add other constraints. There are like constraints like, oh, don't let any values be null in this column. That would be a not null constraint. You can also add check constraints. So for the age, for example, you can add a constraint that makes sure that none of the ages are over 50 or under 18 or something like that. I've not shown that here, but you can pretty easily Google it. They're just like SQL constraints. And oh, I'm just gonna write this out in SQL real quick so you can see what it looks like. Okay, so with SQL Fiddle, it's a bit weird. So on the left side, we're going to do any sort of queries that alter the structure of our database. So like creating tables, dropping tables, modifying how many rows there are and things like that. And on the right side, we can query those tables and view the information in them. And you'll see what this means when we like encounter more SQL queries. But for now, just know that on the left side, we're doing any database alteration sort of statements on that side. Did I do that right? Okay, cool. I can barely see from up here. But yeah, so I've just typed it out. I think it's a bit small, so I'll try to make this bigger. I just typed it out, and this is what the create table statement will look like. Just remember that each of your columns are going to be comma separated. And at the very end, you usually need a semicolon. Some languages, you don't need to use a semicolon, but I think in MySQL you do. Also make sure that you have MySQL up here. That's the language that we're currently coding in. So I can do build schema right here. And it didn't like something. The what? The what? I spelled primary wrong. Okay. I swear I can't see something. Just take out one. Am I at the right place? Yeah. Okay. Thank you. Perfect. Okay. Yeah, so it's not going to show you anything. It's just going to say schema ready, but I will move on to the next slide and you can see how we can actually see our output. So this is the statement that we're going to use, or the query that we're going to use to see what our columns look like. And like I said before, all of our alteration and modification, structural modification statements are going to go on the left side, and all our like view the table sort of things are going to go on the right side. So this statement we're going to put on the right side, and if we run it, we'll get something like this. There's more to the output, but the important part is here. And let's just break this down. So we have the fields listed out. That's ID, name, and age. We can see the data types that each of the fields are. We can see if they allow null values or not. And we can see if they are a primary key or a foreign key or something like that. For the ID, you can see that it does not allow null values, and that's because that is a property that comes with primary keys. They have to be unique and they have to not be null values. And for the other fields, they're by default allowing null values, but if you wanted to, you could put a constraint on that and say that you don't want to allow null values. Okay, let's go through the data types that we have in SQL. There are a lot of data types, but these are the main ones that most people use. So the first one is char. I know some people say char, but I'll just say char because it's short for character. The characters are from 0 to 255, and the default size for the character is 1. So the size parameter, it just tells you the fixed length of the string that you can put into a column with that data type. So it can be from 0 to 255, and by default, it's going to be 1. And the next one, varchar, is a variable length string. And the difference between this one and the one before is if you say define a column with char and then in parentheses 3, no matter how many characters you put in, maybe it'll just be A, B, C, A, B. It's always going to use up three characters of like memory. And on the other hand, if you have varchar and then in parentheses put in the number 3, you can have A, B, C, and A, B, and they will all take variable sizes. It's basically more memory saving. The next one is Boolean or bool. You can put in anything that's not a 0, and it will identify that as a true value. And if you put in a 0, that will identify as a false. For int data types, the size parameter, so ints are obviously integers. The size parameter is going to be, it basically defines something called the maximum display width. It's not very important, not too important for you to worry about, but basically it means that if you try to display a value that requires more than 5 digits, it's going to be padded with leading zeros or truncated. It's a lot of words, but basically it's telling you how big your number can be. I haven't seen people actually use that, the size parameter, so you can just define it as int and you'll be fine. The last one I have on here is the data type, and that's formatted as the year, then the month, then the day. I think there are other date formats, but this is like the default one. Okay, now we're going to go into actually inserting data into our tables. So this is sort of the format of the query to insert values into our tables. You're going to have the insert into keywords, the table name that you're inserting into, the keyword values, and then in parentheses, you're going to have the values for each of the columns that you're trying to insert into the table. So this query inserts one row, and each of the value 1, value 2, all of those are each of the column values. I'm going to give you guys like 5 minutes to try inserting a row into the table we just created. Just remember that these queries are going to go on the left side where we're altering our data, altering the database structure. And yeah, try inserting values like these or any values you want. And if anyone's stuck or has any questions, feel free to raise your hand. Okay, I'm gonna go ahead and show you the answers. Um, Let me just get this. So again, I'm putting this onto the left side since we're altering the database. And it's gonna look something like this. So we have our insert into keywords. We have the table name, which is student. We have the keyword values, and then we have in parentheses the values we are inserting. So one corresponds to the ID, Alex corresponds to the name, and I can't see this last number, but this number 18, thank you, corresponds to the age. And I'm doing the same for Maria, where I'm putting in all the values into the parentheses, and they're all in the order that the columns appear in. So if I run this, it should work. I'm going to show you another example. So this example has two sets of parentheses, and basically what it's doing is adding two rows at once. So you're not like, if you need to add like a bunch of data all at once, you wouldn't have to copy and paste the lines. You can just put them in parentheses one after the other, and this would work as well. Another thing we can do with our insert into is do something like this. So here we have insert into our table name and then two specific columns that we want to insert values into. And then the values keyword followed by the parentheses with the values that we're inserting. So we don't have the name included here, and that's why we don't have to include the name over here. We're just including the ID and the age. And that's enough because we're specifying that we're only entering values into these two columns. Yes. Good question. So, yeah, so if you print this out, and if you're able to see the rows, which I'll show you how to do in a second, the names column for this particular row would show up as null. And that's because the reason that this works at all is because our names column does allow null values. If you remember when we did the show column statement, we saw that it does allow null values. And so when you print this out, you'll see that the name is just null for this row. So I have a question. Can skip here. Okay, what about repeating IDs? Do you think we can insert two rows with where both the rows have the ID 5, for example? Okay, yeah. I'm seeing people shake their heads. So yeah, we cannot do that for the same reason. It's that ID is a primary key column, and because of that, we can't have any duplicate rows or duplicate ID values. We can, however, have two Marias or two people with the age 20, for example, because those are not. Okay, so if we want to see the result of, oh, I'm not sharing the slides. Here we go. So if we want to view the result of all of the insert statements we did, we can put in this query onto the right side of our SQL fiddle. I'll just break this down before I actually type it out. So the first keyword we have is the select keyword, and that just indicates that we are trying to select a bunch of rows from a table. The asterisk indicates that it's a wildcard character, so it indicates that we're selecting all the rows from the table instead of a particular row. The from keyword is going to indicate that we're about to pull data from a certain table, and then we're going to specify the table name, which in this case is the student table, and your output is going to look something like this. So I'll just type this out here so we can see what it looks like. So once I build this schema, it'll let me do a select statement here. Okay, yeah, so that's what it looks like. And we have, I think, 1, 2, 3, 4, 5 rows because we did 5 inserts. We did 2 in this row and then 3 other ones. And you can see that this last row does have a null value name column. And that's because we didn't specify a name over here. Up till this point, do we have any questions? If not, I'm gonna hand it off to Arashi.
Okay, so now that we've learned how to create tables and add values to them, we can start learning how to modify the table structure. Um, so if you have, say you created a table at the beginning, and then you decided that you want to add another column in the student table called GPA, the way you would do this, because you would be altering the table structure, you would have the alter table keyword, and then you would say add column and type the column name and a data type for the table. In the same way, if you want to drop a column, you would just specify alter table, have the name of your table, and then have the keywords drop column and specify which column you want to drop. So let's try just adding a column to our, I can't see. Where?
Like all the way to the right.
This
Yeah,
one?
outside the screen.
Oh. Yeah.
I can do this while you talk.
Okay. So let's go to the text box. Yeah. So we actually need alter table over there too. Okay. So let's see. Where's the pointer?
I'll do it. Hold on. Okay, we got it.
Table student, add column.
Yeah, I got the ad column.
Okay.
This one's
Yeah. Yeah, okay. And then if you go over here and do select star, oop, okay. Let's just run. Yeah, so now you can see that we added a last name column to our database table. And since we didn't specify any values, all of them will be set to null. And since we also didn't add any constraint for the last name column, we can have all of them be null. So we can also change the name of a column by using like alter table, say student, and then we can change the name of a column. So if we wanted name to be first name, instead you would have something like alter table student, change column and the old name, which is name, and then the new name of the column would be first name, and then the data type would just be varchar, I think. You can also modify the data type of a column. So say you decide you want ID to be um like a varchar instead of an int. So say you want to define IDs as like A1, A2 or B1, B2, then you could modify the data type of that column by having alter table student, modify column, and then ID, which is the column name, and specify the data type to be varchar instead of like an int. Yeah, you can also modify the table afterwards by you can add constraints using the alter table command. So say you want to change the primary key or like drop the primary key from your table, you alter table student, and then you could add a constraint. The symbol keyword over here is optional, but name the constraints that you add or delete so that it's easier to delete a constraint if you don't want it. So over here, if you do alter table table name and then you do add constraint primary key, then you can add a primary key to your column. And if you want to drop the primary key, you would just say alter table student drop primary key. And if you want to add like a check expression, so say you had age and you want age to be greater than or equal to 18, then you could just add that constraint. And let's say we name that constraint is adult, then the constraint that we would add, like the command would look something like alter table table name add constraint is adult, check that age is greater than or equal to 18. So let's try adding that to our table. Am I the right? Yeah. Is that correct? We need alter table again, right? that correct? Okay. Okay. Yeah. Oh, I see. Is that correct? Okay. I cannot see. Oh, they don't? Okay. Okay. Cool. So over here, I guess the check constraints don't work in this version of SQL, but like if you download SQL on your like the right version, then this check constraint should work. Yeah. No, you don't need to do that. I don't believe it's necessary. You can try. But it worked? Okay. Oh, okay. Okay. So we added a check constraint. If you don't want this constraint to be there after a certain point, you can also drop the constraint by doing alter table and then dropping the constraint. You can, if you have a name for your constraint, you can just reference the constraint name itself. But if you don't specify a name for the constraint, you can just type in what the constraint was. So something like we named our constraint is adult. We could just do alter table student, drop constraint is adult. But if you didn't name it is adult, you could just do alter table student, drop age is greater than drop constraint age is greater than equal to 18. Any questions? That was a little fast. Okay, can move on then. We've already touched upon foreign keys, but a foreign key is a field in one table that references the primary key of another table. We use primary and foreign keys so that if we want to merge two tables or see the values of both tables together, then we have something to match each row to each other in both the tables. So we can specify foreign keys while we're creating tables by just having a foreign key constraint at the end, where we say, actually, let me pull this up. So we would specify the foreign key constraint and have the column name right after it in parentheses. And then we would have the references keyword and reference the table name of the um, table that we're referencing to and the primary key for that table. Um, Dropping a table is pretty simple. You can just type in drop table and have the table name afterwards. And that will just delete the table from your SQL database. There's a small joke beneath that from like Bobby's Little Tables. So someone named their kid Robert drop table students, and that essentially deleted all the student records in that database for that year. Now we're going to get into data manipulation language, which is basically just how we're manipulating the language, like manipulating the data. We have select statements. So we can have different kinds of select statements. We've only seen one so far where we select everything in the table, where select star essentially selects every row and every column from your table, or like the table that you specify. But say you only want to see one or two tables, or you want to see only specific values in tables that specify that fall under some condition, you could do something like this. So let's try that out. I've lost it again. Let's go up. Say we only want to see the ID and the name. So we would specify select ID, comma name. So over here, we can only see ID and name because those are the only two columns that we selected to see. Now, say we want to see, actually, let me go back to here. Say we want to see only the age of the students, where the student's age is 18, then we can select the specific columns that we want from the table, which satisfy the condition that we specify. So let's try coding that. So say we want to see all the columns. Select star from student. Where age equals 18. Yeah, wait. So then we see only those students whose age is equal to 18. And since we selected to see all the columns, we see all the columns for the students that are aged 18. We can also modify rows. Since we have learned how to modify columns and the data types for columns, we should also be able to modify rows, which in which our data is stored. So you can update the values the update keyword to have the table name after the update so that you specify which table you want to update it. So we would have something like update student, and then you need to have the set keyword where you're essentially resetting the value for a specific column. So you need to specify which column you're referencing to when you want to change something. So say you want to change the age of every student that is 18 to be 19. So then you would have something like update student set age equal 19, where age would be equal 18. So let's try doing that. Oh, yeah. Um, update Student set age equals, let's make this something big so that we can see the change because 19 might not be clear enough. Where is that correct? Equals 18. Yeah. And then we want to do just a select star. Oh, we see that the value got updated. Yeah, so we can see that the age for Alex got updated to 30 from 18. You can also delete a row from your table if you set the condition, say you don't want students that are 30 years old. So you can delete that row from your student, or say if someone entered a negative value but while entering data, you can also do like delete from student where age is less than or equal to 0, or maybe less than equal to maybe 10, because that's a better value for age. So if you want to see that, we can delete. Yeah. And let's make our condition where name, okay, actually let's just do where age is equal to 18, sorry, 30. Yeah. Oh, I see. We can see that the row that we wanted to delete got deleted successfully. That was it for today. So we went over how to create a table, how to add rows and modify rows, and also add and modify columns. There's a lot more you can do with SQL if you check it out online. You can actually order rows and do more complex operations with your data structures. Okay. Thank you for being here.